All right, ladies and gentlemen, welcome back for another round. This is Mr. Doolin. I thank you for tuning in. Today what we're going to do is we're going to take a look at different ways that we may be able to calculate these equilibrium constants. Up till now, we've been focused on using the QCK table to calculate equilibrium values and then plugging equilibrium values into an equilibrium expression to solve for those Kc and Kp values. The second way that we've been doing this is we were talking about solubility equilibrium. And solubility equilibrium, you're using that molar solubility, which is that X value, so that we can actually plug into, again, an equilibrium expression and solve for that K value. So here's a couple of more ways that we might be able to see these calculations involving K. Okay, and so we saw in thermodynamics where we had different reactions and kind of a stepwise reactions, if you will. And I'm going to go ahead and give you some values here. So we have K1. So there's reaction 1. I'm going to couple that with reaction 2. Both are going to reach equilibrium. And then the question becomes, in this particular case, when I add these overall reactions together, I end up with 2A plus B gives me D plus E. And so what would the equilibrium value be for this overall reaction if I'm adding reactions together that have actually reached equilibrium? And so we've seen this. We saw it in thermo. We saw it in kinetics. And so now it's showing back up, what do we do? How do we treat these? How do we solve for K for that overall? Well, it's actually pretty simple. And so I'm going to go ahead and tell you that in this particular case, K equals 50. And hopefully you see that all we do is we multiply those K values together, right? And so if we're going to add overall reactions, all we do is multiply each individual K value to get the overall K. And so we would say that K1 times K2 equals your K for your overall reaction. So that's not very difficult. But I do want to call back on your memory here and have you remember a couple of different things. There was 3 different things that we had at our disposal when we were actually adding these reactions together to try to get it to a target, to an overall, right? Remember, we added the reactions together. That's number 1. So we're going to add reactions, and then I guess you could say cancel our spectators or our intermediates, right? And so when we do this, all we do is we multiply all the K values together. So K1 times K2 ... equals K overall. And that's the example that we just saw. You probably need to make sure that you add into your notes there that we are multiplying all the K values together when we add reactions. Okay, the second system that we saw, or the second technique that we saw that we could do is we could multiply individual reactions to change coefficients, right? Now, when we do this to change coefficients, remember coefficients are actually put into the equilibrium expressions as exponents. And so all we really have to do is we have to think about what happens when I multiply coefficients, right? And so all it is you end up with a K value raised to the n. Whatever your multiplier in is your n value. And so, for example, if I'm going to come up here and let's say I take this, the second reaction, multiply it by 2 in this particular case, then what I would end up with is 10 squared. So notice the multiplier and the what I'm raising the K value to is equal to the same. And in this particular case, K would equal 100 if I were to multiply that reaction by 2. So very important, you want to put down that when I'm multiplying individual reactions to change coefficients, then I actually just raise K to that particular multiplier. It's an exponent, all right? The other thing that we will do, and then the last one, is what happens if I reverse a reaction? So we'll use this one here. What happens if I have to rewrite this as C plus D to get A plus B? How does that change this K value? Well, if you think about it, my equilibrium expressions are really just products over reactions, and I'll go ahead and put reversing reactions down here is my third technique. Reversing reactions, all I'm doing is products over reactants, and so now all I've done is I've flipped those. So now I have reactants over products, so essentially all I end up doing is taking the reciprocal of your K value. So in this particular case, it would equal 1/5, which would be 0.20. All right? And so those are the 3 different ways that we will see like you'll be asked to calculate K values other than using the QCK table or using those molar solubility values. And it's really pretty simple. I guess with this one we have to make sure that we say reciprocal of the original K value. All right. And so we have to understand that these three things, they'll pop up, they'll be contextually embedded inside of a question. And just understand if you're trying to calculate a K value and you're not giving any values at all other than an overall K, then this is what they're probably asking you to do. All right? All right, ladies and gentlemen, that's it. If you had questions, make sure you get them down. I'll see you in tutorials for those. And otherwise, I will see you in class.